Oh, we're going. All right. So a man has 340 yards of fencing for enclosing 2 separate fields. One of which is to be a rectangle, twice as long as it is wide, and the other is a square. The square has to be at least 100 square yards, and the rectangle has to be at least 800 square yards. If x is the width of the rectangular field, what are the maximum and minimum dimensions of x, or values of x? This is a very deceitful problem for an AP test. It's deceitful because it starts talking about the maximums and minimums, but it doesn't take any first derivative test or second derivative test. Those mean people at the College Board in 1972, what's that about? There's no calculus required in Part A. No calculus at all. Right, at least. Any thoughts yet?
2x.
Oh, I like that, 2x. So, oh yeah, they said x is this, and this has to be 2x, no matter what. Those dimensions are set. And this is at least 800 square yards. Alright, what do you think?
Is the min 20 and 40?
20 and 4. Oh, yes. The minimum value of x is 20. Why?
Because that's the lowest number to get 800 whenever you double it.
Good. We have to have at least 800 yards. So it can't be smaller than that. So no matter what, we know that x times 2x has to be 800. Right? So solving this, we had 2x squared is 800. X squared is 400. X is 20. It has to be at least that big. Now, can it be bigger than that? Yeah, absolutely. How big can we make it? This is Texas. It's all about how big can we make it? Could we use all 340 yards of fencing?
No.
Oh. Why not?
240.
How do you get 240?
320.
320. How'd you get 320?
I took the square root
Under
of
100 the
100.
total he has.
Now, I bet if you two work together, you'll both get it right.
Oh. 40, 300.
300.
All right.
Okay, so this has to have at least 100 square yards, which means at the very smallest, this has to be 10 by 10, right?
Yeah.
Which means we're taking away more than 20 yards, but we're not taking away 100 yards. We're taking away just the perimeters. So the perimeters, all of them. Yes, all perimeters. It's 40, so we're taking away 40 yards, which means we have 300 yards left over for this. Cool?
Mhm.
All right. How big can we make it if we have 300 yards of fence? It's been so long since you've done geometry. This feels weird, doesn't it?
It'd be,
50's dang, Tyler. How'd you get 50?
I added up the x's on the rectangle.
Good. So, x plus 2x plus 2x has to be that whole 300, which gives us 6x is 300, and then x is 50.
Wait, can you explain to me why it's 300?
Because there's 340 yards of fence altogether, right? And this thing has to have at least 100 yards, and so to be if we made it as small as possible, so we'd have lots of fence left over for the rectangle,
That makes.
then it's
okay,
40. Does that make? And then this is where it's like, no calculus. This is all part A is. We are done with part A. If you want to write it like super professionally, you'd say X has to be at least 20, but no more than 50. And nowadays they don't really give this type. Hey, Jazzy Jack. Nowadays they don't give this type of problem on the AP test as explicitly. They make this a little bit easier to find. This is really your domain. Oh, let me give Jasmine that. We're on the second one. We're almost done. Sorry.
We got pictures of coffee. They told us last minute, and I already had plans to come here.
I'm so sorry. Colby's recording it for us. We're going to be online. Live.
Recorded.
Shh. You don't have to know that. You're missing this right now. All right. So we've got our domain down, and on the AP test, you never are going to have to write your domain, but you should always be aware of your domain. So in the end, if we get an answer like, oh, x equals 75, a red flag goes off, we're like, whoa, no, it can't. It can't be 75. Okay. Can I erase this part? You ready for part B? Part B. How much area can we enclose the very most?
The total.
Total. Let's say that we want to, put the football team in this field and the soccer team in this field. How much, to take their pictures, how much space can we give them at the very most, all together? That's tough.
If you leave this square how it is and only increase the rectangle,
Yeah.
would it give the highest possibility?
What if we left the rectangle as small as possible and we just made the square super big?
True.
How come that wouldn't be bigger? Or would it?
Well,
Maybe it
the
would.
minimum is 20, and then, I don't know.
You would have to use them together to figure out like the maximum, I think.
Well, yeah.
And we could say, okay, well, we'll try 20 and see what our area is, and we'll try 50 and see what our area is, and see which one's bigger.
Mhm.
That's clever, except what if the maximum's somewhere between 20 and 50? Does it drive you crazy a little bit? What are you trying to do? You're trying to maximize this area.
We have to come up with an equation.
Yes! Yes! Find the equation! And that's what makes these questions, even though it's 1972, so much harder than some of the more recent ones. This question, part A, was much easier than a lot of our recent questions. But the fact that they don't give us any equation at all, and we have to use like geometric formulas to develop our own equation, makes it freaking hard. So, what formulas do we use here? And what you missed earlier, Jasmine, this is the big deal. In every optimization problem, always, the big deal is to come up with some formula that you're trying to min or max. Whatever it's going to be. In this case, we want one formula that we're trying to maximize. I probably won't be able to fit it there with this here. I'll move it a little lower. We want one formula we're trying to maximize, and we're trying to maximize what area? Okay, so let's use area. In terms of x.
We have another variable because of the square, right?
No, just x squared.
Let's avoid having another variable because of the square. Could we just use x squared?
For the area of the square.
Would that work?
It might. Don't know.
Shouldn't?
No, should go rectangle.
Well, the area of a square is the side squared.
Yeah. So just x squared.
So wouldn't x squared work?
But is it not?
What's x1?
X
Yeah.
is the side of the.
X is the side of this thing.
Okay.
Does it have to be the same width over here?
No.
No, that's totally different width. Yes! Isn't this great? Okay, let's just do one step at a time. Let's just write down the area of the rectangle here.
Okay.
Because right now I think what's going to happen, and on your AP test, thinking of a question like this, what's going to happen is you're going to get so overwhelmed with all this, what if this, what if that? And without breaking it up a little bit and saying, okay, well, let's just do one piece at a time, you're going to be overwhelmed and you're going to like fizzle out. But one piece at a time, you'll get through the problem a little bit faster. And you might want to start with the square. But if you start with the square, you'll realize how to put the square in terms of x, because the only value that I want to deal with is the width of the rectangle, x. So let's do the rectangle first. Area of this rectangle is 2x squared. Good? Alright. Now what? We just have to add that to the area of the square. That's easy. Plus
No.
area of the square. Well, good luck. I have. Also, never get discouraged if you come after school, because we do pick. I try to pick the hardest problems I can find.
Which one out of ABC is that, like perimeter or something like that, using the same, or I don't know.
I like where you're going. Keep going. What about the perimeter?
It's at a set, right? You can only use 340
Mhm.
whatever it was, so maybe try to see if you can find like the perimeter of the rectangle, try to get it in terms of the square.
Okay, what's the perimeter of the rectangle?
2x and 2x.
6x.
6x, right? Perimeter of the rectangle is 2x plus x plus 2x plus x. So we have a perimeter of 6x here, and altogether we have 340 yards to use. What's the perimeter of the square? And if you need to on your AP test, like take a break from this and go over and be like, okay, perimeter of rectangle is 6x. That means the perimeter of my square is,
Does it have to be as me?
we have 340 yards altogether
Oh, for both?
for both.
Okay.
So it's 340 minus 6x. And now you can,
And those,
Oh,
in
okay.
terms, so.
All right, so that means the area of the square is,
that divided by
perimeter
4
divided by, yeah.
squared.
Good job, Mom.
does that make sense?
Yeah.
That was so hard.
Wait,
Why are we squaring it? Oh, because it's area.
Yeah.
Never
'Cause
mind.
area.
That's just one
Got it.
side.
Yeah, one side would be this divided by the four sides, because they all have to be the same. And then one side squared is the area. Hard problem. Can we simplify that before plugging it over there? Maybe a little bit. We can do 340 divided by 4. So 85 minus 3 halves x squared. Back in when they gave this problem, I'm guessing they probably were allowed a scientific calculator. We can do it without if you want, or we can go ahead and allow scientific calculator.
No.
Yeah, do no calculator?
Okay.
No calculator. We'll try it. We'll try it. Okay. So, oh, how are we gonna solve with no calculator? Well, but I don't know why I'm saying solve. We don't have an equation. We have an equation, but it's not like it's solvable because we have two variables, a and x. When I say solve, why would I say solve? Silly Mckee. What are we trying to do?
Take the derivative.
We're gonna have to take the derivative of this, and then what?
Find the max.
Set it equal to 0 to find the max. Good?
Yeah.
Okay, so let's take the derivative. I'll do the hard part. That's gonna leave us with 4x, and you all can do this easy part over here.
Thanks.
Not a problem.
Right?
What is it?
Chain rule?
Oh yeah, it's a chain rule.
Okay.
2 times 85 minus 3 halves x times negative 3 halves.
Yes. Everyone good with chain rule? when it magically appears in a problem like that? Okay, I'm going to simplify this one more step just so that we have a prettier equation to look. Well, actually, probably 2 more steps. Just so we have a nicer equation to look at. That would be 4x. Whoa. Minus 255 plus 9/2 x.
Would this be a calculated part or not?
I think, see, this was 72. They may have had scientific calculators. They may have had 4-button calculators. Today, if they gave you this problem, it would be on the calculator part. It would be on the calculator part, then they'd give you a slightly harder function that you may not at all be able to derive by hand. Because the test has evolved a lot, it's changed a lot. And right now they really have, the questions back in like 72 were a lot more like, okay, we're going to mix a little bit of algebra with some geometry with a tiny bit of calculus. And now it's like, when you get to like the calculator portions, they're pure calculus questions. Like they're really asking, can you interpret the calculus? Do you understand what does a prime of x mean? And you're like, well, it's the rate of change, it's how much the area changes as we change this distance. Whereas in 72, they wouldn't have asked that. They were just like, okay, just set equals 0 and solve. So back then the math was a little bigger, but it wasn't nearly as deep as it is now. Now they really want to make sure you understand what you're doing with calculus. So they would make this, because like, what are you doing? Like here down, it's algebra 1, right? So now they don't care. They're assuming that if you qualify to take the AP calculus test, you can probably do algebra 1. And I don't even know if I multiplied that out right. Is that right?
I think so.
17 over 2x is
Did you use the last fraction?
Do what?
Did you multiply the 3 halves, negative 3 halves?
Yeah, negative 3 times negative 3 is 9. 2 times 2 is 4. But we got a 2 on the outside. So I'm pretty sure that's right. Alright, we gotta set this. Oh man, see, not even set it equals 0 yet. We're still just algebra-ing. Alright, 4x plus 9/2 is what?
17 over 2.
17/2 x minus 255. There's our derivative. She ain't pretty, but she's ours.
That's 510 divided by 17.
Yeah.
30.
Oh, that's 30. Yeah. 51 over 17 is 3. Nice. And then on the AP test, do you not feel great when you're working on a problem? You're like, oh, all this crazy stuff, and it comes out to be this nice, pretty answer. It's like 30. You're like, I'm right. I know I'm right. Okay, so Colby said that equals 0. He got 17/2 x has to equal 255. Solve how you're going to solve that. X equals 30. Is it possible for x to equal 30? What does that question mean? What am I asking when I say, is it possible for x to equal 30?
Is it in the domain?
Well, that's
Is it in our
actually-
domain?
Yeah.
Yeah, and 30 is in our domain, so we know we're good with this answer. So is that it?
No.
Would 30 yield the biggest? Is it asking for what the biggest is?
Biggest square yards.
Square yards. Okay, so all we gotta do is plug 30 in, and will that give us the answer?
I think so.
Test it.
Oh, yeah. That's
30 might be a minimum. So we're gonna cross our fingers now and hope it's not. Bad news for you, I think it is. So, let's find out. Plugging in things around 30. Let's go like really big. Gives us a pause. Oh, hey, no, I was wrong. It's a minimum. Oh wait,
Oh wait, no.
we're not looking for a minimum.
Wait.
We're looking for the maximum.
Yeah.
Last problem, we were looking for a minimum. Oh man. Okay. At this point, yes, we'll totally use a calculator because no one wants to plug these things in.
Wait, what would you do then?
Well, so
We
what's it
have a
mean?
calculator.
What's it mean if it's a minimum?
That's the lowest.
It's the lowest point. So then how are we going to find the highest?
Yeah.
Plug into your calculator and graph
Plug
it.
what into our calculator?
The function.
What about the function?
I mean, well, the derivative.
Oh, come on. But if we okay, let's say we plug this into our calculator, right? This function, and we should have known right away that this was going to be a minimum. I really did all this just for funsies, because when you look at this, you say, hey, when you square that, it's going to be positive, plus another positive. We have a positive parabola. You know this is going to go like this. Whee! Which means if you find where the slope is 0, you are finding the vertex, which will be a minimum and a total waste of our time. Nah, suckers. So, isn't calculus aggravating sometimes? But this problem wasn't aggravating because of calculus. This problem was aggravating because of all this like algebra part.
So do we plug in 20 and 50 now?
Yes, because 20 and 59 are critical numbers because they're endpoints.
Yeah.
Okay.
All right. So on the
then,
AP test, this totally counts if you want to do this, because you will have a calculator on this problem. Just set up a little t-table where you're like, okay, for different values of x that matter, 20, 30, and 50. Those are values of x that matter. And then calculate the area for each one, in which case you could just plug that in your calculator and use your table or value to find those numbers. Can you tell, looking at this, which one will give us the maximum?
50.
50. Why?
Because 20 is negative.
20 better not be negative.
Well, I just looked at the slope. It
Yeah.
may not be negative, but it's less than.
Okay. Which one's the maximum now?
Well, 5 doesn't matter.
5 doesn't matter, but let's pretend
Okay.
it is. If 5 mattered, which would give us a bigger area, 5 or 50?
5.
Oh, you're only saying that because I changed the number, huh?
Yep.
But it's still 50.
Oh.
No, I'm just kidding, it's 5. Okay, so let's talk about just analyzing this really quickly using the power of our minds. All right, because plugging these into the calculator and actually getting numbers here is what you want to do on the AP test. Because what you're showing is these are the numbers that matter. They will, 100% of the time, give you a point. As soon as you do this, they'll give you a point. You can even do it earlier by saying a prime of x equals 0. The moment you write that, they're like, okay, there's a point. They understand they're looking for critical numbers. All right? And then the other point they give you is for not just including your critical numbers, but also analyzing your endpoints in problems like this. If they say we have to do at least this or at least that. How did I know that 50 is the max, not 20?
Plug it in.
Without plugging it in.
Yeah, plug it in.
The moment that I told you guys it was a parabola, at that point, that's when I was analyzing this part. When I said, oh, it's a parabola. Duh, it's a parabola. And the vertex is at 30. So imagine a parabola that's going like this. Okay, where's the highest point in this parabola going to be?
Not
The further past 30.
The further away from 30 you go, the higher it gets. Which one's further from 30?
50.
50.
Wait,
So,
what did you
you
say
say
about
50
5? Did you
was?
say 5 would be?
5 would have been bigger.
Why is that?
So it's further away from 30.
It's further away from the vertex. When you're at 50, you might be like here, oh, we're up here. But with 5, whoosh, we're up higher. The further you get from the vertex, the higher you're going to go. Now, that's nothing you would ever write on your AP test. But we always, in these problems, we're always aware of the context that we're working. And when we see, like, okay, we're dealing with a parabola, or we're dealing with time, things like, okay, the further we get from the vertex, the higher we are, and the vertex is going to have a slope of 0, or with time, you can't have negatives. Those things help us analyze the problem more quickly. You know, so because then when we plug things in, we're like, okay, this is exactly what we expect to happen, and then what actually happens, it's like confirmation that everything you knew was right. That was a hard problem.
Yeah.
And very aggravating that the maximum wasn't.
I'll never prove that it wasn't the answer.
Yeah, you did all the calculus part and it wasn't even the answer. Well, that was fun.
Yeah, we're still not done because we have to figure out.
Oh, we have to calculate it.
Oh my god.
Okay, let's just use the calculator on that. Who wants to calculate this in real life? Okay, so let's just, we'll pretend like we calculated these two. It's not that one, it's not that one. Okay, so how big is that? Okay, 50 squared is 2,500 times 2 is 5,000. 3 halves of 50 is 75. 85 minus 70.
10.
10, 100.
5,600.
Yeah, well wait. That should be 5,100, right?
Oh yeah, 100.
Yeah, I'll go with that.
So why was it silly of me to say, okay, 85, okay, so 3 halves times 50 is 75, and 85 minus 75 is 10, and 10 squared is 100. Why was all that really silly?
Because you were just doing that over.
How did we get 50? We did that in the context that this was 10 by 10.
So it's 100.
I already knew that was 10. I should have been like, okay, that's 100. What's left over for the rectangle? Okay, it's been a long day. Let's go home. That was fun. Oh, I love math.